Hey friends! Many of our viewers asked about tips and tricks in our community and in the comments. So in this video, we are aiming to share some of our best practices, tips and tricks, and I'm going to explain them. We are trying a different video format that is closer to a tutorial and requires less editing. The goal is to cut the video production time a little bit, so I can share more knowledge with you. This is an experiment, so please share in the comments if you liked it or not, or if you have any thoughts, suggestions about it. And without further ado, let's get into it. So the first trick I would like to show you is going to be an HTTP node related trick. So let's imagine you want to scrape this page from LinkedIn, which is Hugging Face's profile or company page. And if you copy out the URL and paste it in the HTTP request, after executing, you are going to see that the content is very different. And I can prove it by just taking the URL, searching for it. You can see that it's not available in the response. So how are we going to get around this? Let's take this URL and I'm going to search for it in Google, and let me open the inspector panel. So in here, let's head to the network panel. Let's select a document. So we are going to filters for documents inside. And after clicking on it, you can see this was the document request inside Chrome. Click with the right click and copy the C URL. And then go back to n8n and we can import this URL here. So after doing that and executing the step again, let's copy this again. And then, oh, I just want this one. I don't think it's wrong. There it is. So you can see that now we do have a match. So why did this work? The CURL has all the parameters that Chrome sends. For example, the different headers it sends, and that includes all the cookies as well. So at the end of the day, the request is going to look like it's coming from the browser instead of n8n, and it has the right parameters as well. So this works in, like, I'm going to say like 6 to 7 out of 10. But there are some methods that were implemented by providers like Cloudflare, who works on preventing people to scrape other people's sites. So they have more sophisticated tools that they use to recognize your behavior. So just be aware. And yeah, that was the first trick. All right. So the second trick is going to be about data, and namely extracting structured data from text. Many of you asked, why are we using structured data like JSON more particularly? And I would like to explain why, and I also would like to show you a couple of different ways of achieving this. So let's say our task is to take this site or take this company page. And what we want to do is we would like to extract the data that is here. So basically, we would like to get the website, the industry, the company size, type, founded. So these are more data fields. So if we would instruct an LLM, you could get, you send text in, you get text out. So basically you are limited to get one response at a time. So you could say that, let's say we want to get the website, and it would return only the website for you. But if you want multiple data points and then you also want to use it, then you will need structured data. Of course, you could create some tricks theoretically. For example, you could ask it to return it in a certain order, like separated by commas, for example. And that could also work technically, but there are a lot better ways. And this is where JSON comes in, and especially useful if you want to create more deep data structures. Let me first find some CSS class that we can target so we can work with this data. I can see that this is where we can target it. So we have data test ID. I'm going to copy this and go back to our example. So, and I'm going to pin this so we don't need to request it all the time. I'm going to use an extract node and let's call this about us. And the selector is going to be a section where we pass in this test ID. And we also want to get HTML instead of clear text. So you can see that we do have the data that we were looking for. So just to demonstrate, I'm going to use a basic LLM chain that takes some text, and I'm going to pass in this HTML that we have, and let's also add some instruction. And I'm going to say that extract the company website URL from the text below, and we'll also add the text. So the only thing we need is a model. So I do have one running. I can use Olama, but feel free to use like any other chat model. And I think I'm going to use Quen. Let's use this model. And well, the problem with Quen is that I do need to send a no think, and it's going to return a think token. You'll see in a second what I mean. So maybe this is not the best example, but I'm gonna fix it in a second. Let's wait for the model to respond. Oh my, I see what I did here. It's no think. It's going to be a lot faster without thinking. So you can see that we do have this thinking token here. And then the other problem is that like the URL itself, it's not usable. So you still need to work on the text to do something with it. So how can we get around this? One way is to add a structured output parser. And in here, you can say that you are interested in the website. So there are two ways to define how the structure should look like. One is you can generate an example here, and then you can use that. So if I run this again, I would get exactly what I was asking for. And you can do this for, different formats. Sometimes I get into trouble with this, and I start to get weird responses. For example, the response that came back cannot be fit with the structure that you send, or it could also be like out of order or not what you were looking for if you are trying to create a nested data structure. So in those cases, you can use the define below, which is like expecting a JSON schema format from you, which you can write by hand if you know how to write it. And it's fairly easy. So you can see that there are the properties, and then you can say that this is the, let's say, the website. This is a string. We'll delete the cities from here. And if we use this, you get exactly what you expect. But also, if it gets more complicated, I'm using this JSON schema builder, which you can just add the properties to. So website, it's a string, it is required. And then you can also add the description to it, which is the extracted website. And if you click on the schema, you can copy this and come back, paste it in. You see that now it has a description field compared to the previous example when I manually did it. And then it has the required field for the website. Now, if you run this, we get the exact same output. And where this gets very useful is if you want to create, let's say, like an object that has an array inside, and that array is, let's say, array of numbers. So it could easily get a lot more complicated. And in those cases, you can use this designer to easily create them using this user interface and then just copy and paste it. I'll drop the link to this tool in the description. Let's move on to other ways of extracting data. So I find the structured output parser very, very useful in cases where you need deep structure. However, if you need some basic data, and I'm going to disable this for now, you can use the information extractor node, which, let me connect it to our model. And I'm going to use the same text here. And I'm going to define some, I think I'm going to go with these attributes. That's the easiest way. So let's just remind us what we want to extract from here. So we have the website, let's say the industry, and the founded. So I'm gonna target those. This is going to be the website of the company, and it is required. Then we'll have the founded. And yeah, let's get the industry as well. Should be enough. And everything is required. So if we execute this, we are going to, well, it's probably the thinking tokens again, which I can get around very easily, but you can see that we were able to extract the data that we were looking for. And we just actually do the I'm also happy with this, but I'm going to do nothing here. Nothing is only required for Qwen, just an FYI. So if you're using other models, you don't need to do that. There it is. All right. So let's imagine we want to extract the different specialties. You can see that this is a list which is separated by comma. We could use the information extractor to extract the whole string, and then we could work on it. So that is one way to see, we want the specialties required. So you can see that we do have the list and it's comma separated. And then what we could do in the next step, for example, we could use some JavaScript to split the text based on the commas, but we can do better. So I'm going to get rid of this information extractor. We don't need this anymore. Reactivate our beloved LLM chain. And in here, I'm going to go back to our data. And actually, I'm going to go back here. And oh, I think I just deleted the wrong one. But fear not, it works vice versa. So you can paste in the schema that you already have, and then it's going to be in the editor. So let's add another data point, which is going to be the specialties. I hope I don't have a typo. And this is going to be an array of strings, which is still required. I'm going to add some description, which is the specialties. And I think this is fine. So now if we execute this step, you can see that we have an array now with these data points, which is exactly what we wanted. So in some cases, this still isn't enough. And you're going to get an error message that JSON output from the LLM cannot be fit to the JSON schema that it is expecting. So in those cases, you can toggle this toggle the retry on fail, and this is going to retry to get another output from the LLM and parse it again. So I hope this was useful. And this was the second tip. The next tip is going to be about the HTTP nodes again. So there are two things I would like to show you. One is you can reuse some of the credentials that you already have defined. So for example, I have an OpenAI credential that I use to talk to the GPT APIs, and in some cases the release is faster than the nodes, like the node development at n8n. So there are some features that aren't available, and at the time when we were creating this episode for creating the Instagram influencer, the image generation for GPT wasn't available yet. So we had to use this custom API call where we reuse the credential type. So it's very simple. In the authentication panel, you can select the predefined credential type. And then once you find the OpenAI that you, or any other one that you would use, then that will be used for authenticating that HTTP call. And another example is, for example, the YouTube node, because the functionality to upload a thumbnail is missing. However, you can reuse the YouTube authentication in a custom HTTP node, and you could just send the thumbnail there. So that was about the pre-configured credential authentication. I have another example where I use Google API key to authenticate. And this endpoint, it expects the key to be sent as a query parameter. So I'm using the generic credential type, and I already set this up. You can see here that I have the key as a query parameter, and the value will be sent, and it is stored as a credential. So that was tip 3. As tip 4, I'm going to talk about basic LLM chains versus the AI agent node. And I'm going to give you my 2 cents. So for me, and let's talk about this particular scenario right here. I am a control freak, and I like to know where the data is flowing, what amount of data I'm passing into the LLMs, so I can control the amount of tokens it is using. And in this scenario, you can see that we had the HTTP call, then we extracted the HTML, so we stripped it down, and then we used that to work with. Imagine instead of using a basic LLM chain and then extracting it and then using the request on your own, you could add tools to this agent, and it would do the same thing. However, on every single call, it would use all the data that is here inside this one particular page. So if you would do this with multiple pages, you would end up using up a lot of tokens. And in the past, I had an example where I was, I just gave it a bunch of tools, and I suddenly got an error. And in the error, it was saying that I'm out of quota and I cannot make more requests. And it turned out that the AI agent was trying to send 500,000 tokens to the GPT-4o at the time, which was I think I was tier maybe 1 or 2. I'm not remembering it, but basically for me, in most of the situations, I'm trying to make or create basic LLM chains, and I model everything, so I know exactly what is happening, and there is less magic. In the future, I would want to see from these nodes that they provide ways to save tokens and not to just dump a bunch of information on these, or maybe we'll live in a future where tokens will be very, very cheap, and then they can have a context window of tens of millions of tokens. So we don't know it yet, but at this point in time, I prefer using the LLM chains over the agents in most of the cases where it's an automation with a control flow that I want to implement. So there are other cases where the AI agents could be useful, for example, chatting with the user with audio or text. That was this tip. Let's move on. Before we jump into the last tip, let me just mention that we recently started a Skool community. And in this group, we are going to share many premium workflows and databases that we script and other tutorials and courses about n8n and on how to make money online, how to create or generate YouTube videos with automations and more. So if you are interested in it and you want to belong to a great community, we are waiting for you. For the last tip, I'm going to talk about databases. Someone asked why we are using a Supabase database for the revenge story creator that we made, and why didn't we use instead a Google spreadsheet or an Airtable or something more simple. And my response was, we want to create something that is scalable, because all these documents are like good enough to create something simple, something fast. However, when it comes to a large amount of data, and you don't need to imagine like a ton of data, it could be as large as 1,000 rows, for example. So if you get to that level, the whole automation is going to get gradually slower and slower. I recently saw, for example, one automation completely making my browser frozen. So I do recommend using databases where you can expect the workflow to be scaled up. So that was one of the reasons for using it here. Let me show you another example I used. I have a lot of bookmarks here that I wanted to process, and I have a status field where I am setting the status based on an output of an LLM. And in here, instead of talking to the REST API of Supabase, I connected it as a Postgres interface. It's a lot faster that way. And you can see here that I have a loop that is processing it one by one. That was the most efficient way for me to design this automation, because every time it runs, it only takes one single data point that it needs to process. It makes the processing, it saves it back. And this way we are not like overflowing the memory immediately. Instead, if you can imagine just having a large CSV file or a spreadsheet, you would read it into memory at the very beginning in here, and then while you are processing and writing it back, you would need to update it. So it would be a bunch of extra data slowing down your browser and essentially your n8n instance. All right, that was it. If you liked this new format, please leave a comment, or if you didn't, please let me know or let us know. And as always, I'll see you next time. Bye-bye.